All right, in the last section of Chapter 2, we're going to talk about perimeter. So the perimeter of a polygon is the sum of the length of its sides. So let's say we just had a 5 by 16 rectangle here. All that I would do to find the perimeter is I would add up all the sides. So 16 plus 16 plus 5 plus 5 would give me 42. Now let's look at an example problem where we kind of got to use the distance formula and stuff that we've learned so far this unit. I want to find the perimeter of triangle EFG, and we can see all the coordinates and it's graphed to the left of us here. So the perimeter would be adding EF plus GF plus EG. So all three of those sides of that triangle, I'm going to find the lengths of all of them and add them together. Now to make my life a little bit easier, I'm going to look at this graph and I'm going to notice that I can just count the length of EF and GF because EF is vertical and GF is horizontal. So I'm going to count this side length. I'm going to find that EF is 8 units long, GF is 6 units long, and finally for EG, I'm going to have to use the distance formula here because I got a diagonal line and I can't count like that in a coordinate plane. So I have my coordinates for G and F, so I'm going to use the distance formula. The change in X is 6 because there's 6 units from -3 to 3. So I'm going to do 6 squared there. And then the change in Y is 8 units going from -2 to +6. So in my calculator, I'm going to do the square root of 6 squared plus 8 squared, and I get 10. So finally, my perimeter for that triangle is going to be 8 plus 6 plus 10, which is 24 units. Now let's look at one more problem. This one's going to be a little bit tedious. This is the last one that we'll do for this video. Triangle ABC has the following vertices. A is at 410, B is at -412, and C is at -2, I want to find the perimeter of this triangle and round it to the nearest tenth. I'm not given a graph here, so I'm going to probably have to do the distance formula here for all three sides. I'm also just going to sketch out some triangle ABC just so I can kind of piece together what are all the side lengths that I need to find. Looking at that, I know that I need to find AB, add that with AC, and add that with BC in any order. So let me start with finding the length of AB. I have the coordinates, I'm going to do the distance formula. So here I would have 8 squared plus 2 squared for my change in X and change of Y, and that's going to be the square root of 68. Now for this problem, I'm going to round to the nearest tenth, but that's not until the very end. I want to be careful that I'm not rounding at each step because then we can kind of create a bigger error than we want to. So I'm going to keep this as a radical or as an exact answer until my very last step here. So I'm going to leave this as radical 68 and move on. So now I want to find AC. So 410 and -2, are the coordinates that I'm focusing on. My change in X is 6. My change in Y is 5. So I'm going to do the square root of 6 squared plus 5 squared. And I get the square root of 61. Again, I'm going to leave it as a radical now. Find my last side length. For BC, my change in X and change in Y is 2 squared plus 7 squared. And that's going to give me radical 53. So now I'm going to plug this into my calculator. Notice here, this isn't one big radical. It's radical 68. I'm out of the radical now, plus separate radical 61 plus a third radical 53. I put this all in my calculator, and I end up rounding to the nearest tenth and getting 23.3, and that is my final answer.